Yes, class, am I audible to all of you? Austin, Humam, Madiha, Tarif, Shahid, Chavez. Faiza is joining. It's audible, no? Okay. So yes, we have started with self-induction in the last class yesterday. Let us quickly complete this mutual induction part. This is also left. But before that, no, one question let us practice. This says that a 12 battery connected to a 6 ohm 10 Henry coil through a switch devices a constant current through the circuit. The switch is suddenly opened. If it takes 1 milliseconds to open the switch, find the average EMF induction across the coil. See, when you get such types of questions, no, then do not focus on the story part, that if it takes this, then what happens. First, to write all the data that is given to you. If you have all the data that is written, you will be able to write this. Files. All right. So yes, 12-volt battery, this is connected. Huh? So I was saying just write the data that is given to you. Voltage is 12 volt, resistance is 6 ohm. This is what you have. You have L also, value of self-inductance, that is 10 Henry, and time also is given to you. See, we do not know in our formula, E is equal to minus L di over dt. What is EMF? That is the value of voltage. This is EMF. Okay, this EMF is not given, voltage is given. Fine, so EMF is unknown. We have to find it out. L, value of L is also given as 10 Henry. Current and time. See, time is also given as 1 milliseconds. 1 milliseconds means 10 to the power minus 3 seconds. Now current is not mentioned to you directly, but instead of that, it is mentioned that voltage is 12 volt and resistance is the 6 ohm is the resistance. So using V is equal to IR, that is your Ohm's law. That's why I was telling you constantly Ohm's law will be throughout. Not only here, in your semiconductors also, that is a part of your electronics. There also you will have the Ohm's law's application. So current will be 12 divided by 6, which is 6 amperes. So this current is 6 amperes. So we just have to put in the values of this. EMF will become current, this is 10 into, what is the current? 6. No, current is 2. This is 2 amperes. No? This is 2. So this is 2. Li over T, that is 10 to the power minus 3. This goes up, that becomes 2 into 10 to the power 4 volt. This is it. Now coming to mutual induction. Mutual induction, okay, do one thing. First note it down. Note down this question and the solution. Then we'll start with mutual induction. Mutual induction is the last topic for electromagnetic induction. Then we have alternating current.
Can you scroll up?
Yes, Shahid, regarding the negative sign, no, which you are asking, see, it is saying that the switch is suddenly opened. So if the switch is suddenly opened, it means the current was initially zero. So when you'll calculate the change in current, no, this will also be negative. It's actually 0 minus 2, not 12, sorry, 0 minus 2. So that becomes minus 2. This becomes minus 2. So now when you substitute this negative sign and this negative sign, both become positive. That's why initially only I didn't put it. Okay, Shahid? Okay. Uh, Next topic is mutual induction. See, self-induction was what? Self-induction was within the same coil, we were having the changes. Magnetic field was increasing, magnetic flux was increasing, and then EMF was generated within the same coil, right? Now, if there are two different coils, means because of change in one coil, there is EMF induced in the second coil. This is what we call as mutual induction. Fine, that is the basic difference. See, I'll tell you. Suppose this is a coil. This concept is used in alternating current as transformers also. So we'll be doing this again there. So battery is connected. Key is placed. You can place a rheostat also, that will also work. Battery, key, rheostat. And this is our primary coil. Then we have a secondary coil. And we have just placed a galvanometer. It's fine. Now see, if current increases or decreases, what will happen? Magnetic field will increase or decrease, flux will increase or decrease. So ultimately an EMF will be generated in this coil. So changes are occurring in the primary. This is the secondary. And in the secondary, you are able to see the changes in EMF, that is induced EMF is being generated. This is what is meant by this. Now it is a phenomena of production of induced EMF. See, this is what I said. No, it is the phenomena of production of induced EMF in one coil due to change of current in the neighboring coil. So flux here is also directly proportional to current, same thing. Here you will get a constant, that is Mi. What is mutual induction? This is the coefficient of mutual induction. M is the coefficient of mutual induction or mutual inductance. All right. The way we had now phi is equal to Li. Same thing we are having for mutual induction. Fine. Now, same formulas will also be the same. You will have EMF is equal to minus d phi over dt. So EMF will be equal to minus md I over dt. So from here you can take finally minus m di over dt. Same types of questions. Everything is exactly the same. SI unit is also same, 1 Henry. All right. SI unit is also the same over here. One more thing, class. Sometimes you are asked to define 1 Henry as well. So how will you define 1 Henry? See, mutual induction, this will be EMF divided by di over dt, right? How? E was m di over dt. So m will be E divided by this entire term, right? This is going to be E is equal to E di over dt, because this will come in the denominator over there. So what has to be the SI unit? SI unit is actually 1 volt per 1 ampere per second. So you can write this as 1 volt per ampere, but this doesn't make any sense. This actually is 1 Henry written. Fine, the SI unit is 1 Henry. SI unit is 1 Henry only. So we represent it through H. Now what again is di over dt? Di over dt, this is the change in current. Rate of change of current. All right. Mutual induction, I'll do it later. First, understand this. This is exactly what you have studied in self-induction. If I note it down, then we'll see mutual induction in long solenoid. That would be the end, because questions are also just exactly the same that we have practiced. You just have to put in the values. See now mutual inductances for a solenoid. So when we had the self-inductance, yesterday we saw it. So only one coil was enough, right? We used the formula B is equal to mu naught I and just kept it. Right now also we are going to do the same. It's just that we are taking two coils now. Two solenoids we are taking, because in one current will be changing, in another one EMF will be induced. In the same coil within the same solenoid, the current was also changing and the EMF was also being produced. So see, 1 and 2, I have just named it. One is this first coil, orange one, and the blue one is the second one. So everything is written radius. R1 is the radius of the first one, R2 is radius of second. Current in the first coil is I1, I2 is the current in the second coil. Length of both the coils will be the same. In your syllabus, length of coils will be the same. Even if it's not about the syllabus, more it is like, even if see, I am taking a very long coil. Suppose the current is being induced change here. So EMF will be produced here only. So ultimately length will be this only same. So that's why we will just consider the same length. Number of turns in the first one, number of turns in second one, N1 and N2. See, when I say 5, 1, change in flux in first one, magnetic field that is being changed is of the second, right? When I say 5, 1, that is the magnetic field is being changed of the second coil. The magnetic field of the second coil changes. So that's why magnetic field, I'll put it as B2. Rest of it, area will be the same. We write now BA cos theta magnetic flux. And here we have number of turns also. So we have to put the number of turns also as N1. N1, A1, phi1, this is clear. Why B2? Because magnetic field is changing in the second one. That's what we are studying. And what is B2? B2 is for the second coil. B2 you can write it as mu naught Ni. So for the second coil, B is equal to mu naught N2 I2. So what flux will now become? If you put this entire part, this becomes mu naught N2 I2. This is magnetic field, area into N1. Now what is mutual induction? Mutual induction is phi divided by current. Phi is equal to Mi. So M will be phi divided by I. In mutual induction also you have to specify which one you are considering, mutual induction of first due to second or second due to first, because both are possible in this. If I consider phi 2, the magnetic field that will be changing, I'll consider of B1. B1 will be considered. So that's why we have to be specific. Like if I am writing M12, this is mutual induction of first with respect to second. So this becomes phi 1 divided by I2. Phi 1 divided by I2. Fine. So phi 1 is what? Phi 1 is mu naught into I2 A N1 divided by, because current is also changing in the second one, divided by I2. Yes. So I2 will be cancelled. Now regarding the number of turns. Number of turns, if you want, you can elaborate and write it. All right. Anyway, this is fine. For this, I'm saying N2. If you want, you can write N2 as N1, N2 divided by length. This also you can write. So this formula is also valid for M1, 2. Fine. If just I want to do the opposite, I will take B1 first, mu naught N1 I1. Then I'll consider phi 2, which is being changed of first one in the second coil. So this becomes mu naught N1 I1 A into N2. Same derivation it will become. Now what will be? This will be M21, which will be equal to phi 2 divided by, now current will be in the first one. So this becomes mutual induction of second with respect to first. The way we write relative velocity, VAB, velocity of A with respect to B. Similarly, this is how we will write it. So this becomes mu naught N1 N2 A divided by N. This will be the same. See, current will be cancelled. N1 and N2 both are present. So you will get the same result by both the means, right? So what you can conclude? You can conclude that M12 is equal to M21. You can conclude this fact that M12 is equal to M21. Sometimes in the question, this can be asked to you to prove that mutual induction of first with respect to second and second with respect to first, both are exactly the same. So this derivation you have to show. All right. One more thing that is there in your syllabus is coefficient of coupling. Now, don't go into the details of coefficient of coupling. One more thing. Here, when the area part is asked, no, here, mu naught N1, N2, A by L for the mutual induction, whichever mutual induction it is. For area for all different types of figures, place it. If you are having, see, for solenoid, what do we have? Solenoid is a circular figure itself. The turnings are in the form of circle only. You do not have square. Usually you do not have. So you will have to put it as pi r square. For this purpose, we are having R1 and R2 radius. I specified initially R1 and R2 for this purpose. Now, coefficient of coupling is just that. You have to remember coefficient of coupling. See, this is just a constant. It's just a constant. It does not have any physical meaning or any significance. What's the significance? It's just there is only one significance, which means if two coils are present, fine. So mutual induction is existing between them, right? Mutual induction is existing between them. Plus, if mutual induction is existing between the two coils, within these two coils, self-induction will also be existing. This coil, this is having this and this, they are having mutual induction. So mutual induction will occur, self-induction will occur within this coil also if current is changing. If current is changing here, then mutual induction will occur here also. So self-induction. So you will have all the three together. So coefficient of coupling is just a formula that connects you with L1, M, and L2. See, mutual induction is the same. It is between the coils, but self-inductances are different. You have two self-inductions value. So formula of K is mutual induction divided by under root L1 into L2. This is the formula of it. And value of K, this is between 0 and 1. This lies between 0 and 1. Fine. This is all about mutual induction, self-induction. Induction is important from your EMI. Laws, Faraday's law. See, this is a very short lesson. So everything is important from this lesson. But you have Faraday's laws of induction, EMI. Those are important. Then this induction topic is very important. In between, motional EMF and every topic is present, but Faraday's laws of EMI and induction, both are important. Anyways, do not leave anything from this lesson because this lesson is itself a very short chapter.
can just scroll. Yes, sir.
C class. Now your chapter 7, that is alternating current. So till now the type of current that we have discussed. See, what's the difference between an alternating current and what's the difference between means the difference between alternating current and direct current. The current that we have been studying till now, this is a direct current. All right. Now the current that we'll be studying from now onwards, that will be alternating current. That's why we have a special lesson for this, that is alternating current. Now, what exactly was direct current which we were studying? See, direct current, whenever we had solved the questions, one value of current was given, right? Even if a current was changing, the current changed to a certain value and it got fixed. Currents, you cannot see any variations in the values of current, right? For example, the last question that we did, current came out to be 2 amperes. Yes. So 2 amperes is fixed. That's it. You do not have t in your answer, you do not have omega, you do not have x, you do not have any other variable which is present. So that is meant by a direct current. Direct current is just a constant current that is present in your system. In all the questions of current electricity, whenever battery was connected, it meant a certain amount of current is flowing. When I say current is increasing or current is decreasing, that doesn't mean the current is variable. See, please class understand the difference between AC and DC, because in your questions right now, you already know that we are studying AC, so we'll be dealing with all the lessons of AC and the concept of AC only. In your exams, questions on AC and DC will be mixed. In AC, you will have questions of DC also, right? Now, after studying AC, you will have questions mixed with DC and AC. So it's you who has to identify. So please pay attention, and whatever doubts you are having right now, only get it clarified. Because once this basic is clear, this chapter is not very difficult. See, it's difficult. It's more difficult than EMI. EMI is the easiest lesson. From your first book, the best lesson, easiest lesson is EMI, then your EM waves, then your chapter 5th or magnetism. That is also a little boring because we have to learn so many things in there. But EMI is a very easy lesson. Every questions are very direct. AC is also not very difficult. All right, if you just understand and revise this lesson, some students, they have very difficulty studying in this lesson. Why? Because they are not thorough with integration. I'll suggest all of you revise integration once. You will have a whole week time, right? Next Saturday, now we'll be having the class, we'll be completing with this lesson AC on next Saturday. So one complete week is there. Revise your integration. This lesson is full of integration, average values, RMS value, every value is calculated using integration. So revise your integration. Now, when I said in the last class regarding induction, I mentioned that current increases or changes. So the change in current, change in magnetic field, change in flux produces EMF. So was that an AC or DC? See, that was also direct current, because the current changed to a certain value and it got fixed. If the current is variable, it means the values are fluctuating. Initially, it is increasing, then it is decreasing, then the values again increasing, it decreases a little, increases steeply, then decreases slowly,
Ma'am,
like this. Yes.
ma'am, you mean there is a variable in front of a current?
Yes, that's what I'm trying to mention. Difference between variable and a constant current. Even your current can change. You can increase the current. You take a higher voltage of battery, you decrease the resistance, your current will increase in your system. But that will be constant. First, let's say I have taken 2 amperes. Fine. Now the current has increased to 12 amperes. Now that's fine. That this is 12 amperes. Now the wire is having 18 amperes. Fine. That is fixed. Once it was 6 amperes, 8 amperes, 12 amperes, whatever values I've said, it remained on there. It's just that we are changing the parameters. That's why current change got fixed. Then I again increase the voltage, decrease the resistance, current increase. That's it. That is a direct current. It's a constant current. Values do not change. And this is a different case. It can happen once value you have fixed, that remains throughout the 7-year circuit. So many questions we practiced where we had chosen one only value of current. Most of the question, I think rarely there was a question where your current increased to a certain value or decreased. Most of the values, current's value was given like this. So that is a direct current. What exactly is a direct current? Value with respect to time is not changing. This is remaining constant. But if the value in your circuit is changing by itself, it's increasing, decreasing, it's changing by itself, that is alternating current, which is new to you. Suppose at time t current is increasing, then it decreases, then it further increases, then it further becomes zero. Now, how the variation occurs in alternating current? It's not like you will have an improper graph. Current is increasing, then decreasing, then increasing, decreasing, like this. No improper graphs are present. How the current changes? Current changes sinusoidally. Current changes sinusoidally. Sinusoidal means it's a sine curve or a cosine curve. Cosine curve is also, this comes at a very late stage. Sine curve means the sine, cosine, tangent, all the trigonometric values we have. This is not what is alternating current. Alternating current has a specific pattern. It will increase, then decrease, it will increase, then decrease in the form of sine curve. Cosine curve is actually, it starts from a higher value and then decreases and then increases like this. This is the cosine curve.
Ma'am, cosine means cosec.
Yes, yes. It will start from the maximum value. This is the zero value. Sine starts from zero. All those students who are having mathematics, I think they will be aware of this already. Sine curve, cosine curve and all. So this is what is meant by alternating current. So this you have to identify through the graphs, through the values. If I give you, have you ever witnessed a question till now, which we have discussed in our class, that voltage is given this, resistance is given this, and the value of current is 5 I cos theta? You have never seen this type of question. We have a current 5, so 5 ampere hi rahega. It won't change. But in alternating current, the values will keep on changing depending upon omega, depending upon time. You have different parameters in your questions. EMF will also be changing. Current is changing. EMF will also be changing. Resistance will be fixed because resistor is not a part of your AC. Right, resistor, you have inductors over here. You will be having a new device, inductors. Resistors we have studied in current electricity chapter 3. Capacitors we have studied. Revise this, see class, write it on the top of your registers what all things you have to revise for this lesson. One thing I'll tell you, see, once the lesson gets completed, there are two groups of students, exactly two groups. Nobody is there in between. One who love this lesson and have understood it completely, one who are facing so many difficulties within this lesson only. Why? Because this lesson is not difficult. If you are thorough with your basics, it's actually very easy and it's a very short lesson. This will not take much of your revision time. But if you people are not studying it day by day, then it becomes a burden. So write it. Integration, you all will revise all the basics of integration. If you want, I can share my video lecture also with you of integration that is covered in some 11th batch or in your batch. Integration you will revise. You will revise resistors from your current electricity, chapter 3, and you will revise capacitors from your chapter 2, that is potential and capacitance. These three things, these are homework for your entire week. These three things you have to do. All right, rest of it that will come because I cannot repeat the entire capacitance. And now at then you will be having a circuit mixed up. Inductor will be present, resistor will be present, capacitor will be present, charger also will come into action, current will also be present, right? So for solving the entire circuit, you have to have these devices connected. See, capacitor will be connected in parallel with inductors. Inductors and inductors will be connected. Inductors we will do because that's a new topic. Inductors the same. That will follow the same laws of EMI. That is related to EMI only. So EMI in anyways, you people have done it earlier. Note it down quickly. This part is clear. What is the difference between a direct current and an alternating current?
Yes.
Others, only Chavez has understood. Austin, Humam, Faiza.
Understood.
Madiha, what about you?
Understood, ma'am.
This is sinusoidally, sine curve. Sinusoidally means it is varying with sine curve. Sine curves and cos curves, every value has its graph. So in alternating current, we have sinusoidal curve. Means the variation is in this pattern only. There isn't variation like this. When I say no, current is variable. So it could be anything. It could have been like this, any random curve. But no, this follows a similar pattern to this, exact pattern to this. Cos will also be used, cosine. But that we'll see later on. Firstly, this is the basic. Whenever you have to answer what is an alternating current, so the current that varies sinusoidally. That's it. Fine class, see the next topic, that is AC dynamo. No? So it's a lengthy topic. We'll now do it next weekend. So what all three topics I have told you, please study and come. I'll not ask you to read it out or just tell me what you've studied. As soon as it will be coming, you will only be facing difficulties in it. So revise and come next weekend we'll meet. Okay class, thank you so much.